All right, so today's video got a cool test for you. So we are going to see the effects of fuel pump wiring. So if you've ever discussed fuel systems with me, you know pretty much wiring. My background is in electronics and wiring. That's what got me into fuel stuff initially, was the wiring side of the house. Um, but it is the most overlooked thing when trying to upgrade your fuel system, even though it's the most critical. Like literally, it's the best mod you can do for performance, and it's typically not very expensive. Typical 10 or 8 gauge wire kits, 35, anywhere, 30, 40, 50 bucks for some better wiring to support your higher flowing pump. You're putting in a pump system that flows double or triple stock. The OEM wiring isn't going to be able to support that. So we're going to actually do a test today to simulate current draw and flow, any flow variance we get based on wire supply to the pump. Because the pump's got a DC motor in it, right? That motor, the cooler it runs and the less current it draws, the better it's going to flow. The phenomenon is called hot flow loss. So the hotter it is and the more current, it's going to output, the fuel temperature is going to raise, and you're going to have pumping losses or flow losses from the density, right? That's the basics of it. So in the rig, I have an F90267 TI Auto E85 Walbro 450 pump. They actually flow 430 liters per hour at 40 psi, right? So I have it in the rig. And first I'm going to do a control test. Then I'm going to do, I'm going to splice in a 15-foot. All right, let me go to these links real quick. So I measured the stock fuel pump wire on the 05 to 10 Mustang is 16 gauge, and it's about 24 feet. So that runs from the fuse panel under hood through the firewall over to the driver's side foot floor area, right where the inertia switch is. It runs through the inertia switch, and then it runs all the way back to the trunk to the FPDM. It's about 24 feet when I measured it out. So I have 24 feet of 16 gauge wire. And then in my kits, I run 15 feet of either 8 or 10 gauge, depending on the application, directly from the battery, straight back the driver's side of the car, across the back of the trunk to the FPDM. So again, I have 24 feet of 16 gauge and, 15 feet of 8 gauge. So it's in there. We'll go ahead and turn it on, and I'll get the control numbers first. So I'm at 13.5 volts, 16 amps, 1.9 is my flow, 40 psi, right? And then set you down so I can record these numbers. So like I said, when the pump draws too much current, it increases heat. Heat is counterintuitive to performance of a pump and a motor and flow, the performance of your fuel pump, right? So actually, I should be checking temperature. Give me a minute. Let me get my... All right. I'm a little temperature gun too. So before I set you down, this will be like the control test. The wiring is like 59 degrees. It's been running for like a minute, so try to run them all the same. 59 and 72. Okay. I'm going to add temperature to this. I think that's pretty relevant. Let me write that down before I forget it. Wire temp was 59 degrees. Pump temp was 72 degrees. And then amperage was 16. Flow is 1.9. And we'll go ahead and shut it off. So we had it running for about a minute when I took those temperature readings. And 1.9 is expected, and that's running through like 2 feet of 12 to 10 gauge wire on my test rig here, so not much wiring. So it's ideal. So 1.9 times 227.125 should be, 432. So that's advertised flow rating of the pump at 40 psi, 432 LPH. So that's cool. Yeah, so those are our control numbers, just running the test rig. So now I'm going to put the 8-gauge wiring in line and we'll test again. So basically all I'm going to do is disconnect my power wire here. The other side. And just plumb it in line. So this would simulate running on 15 feet of 8-gauge wire to the pump. Turn it back on. So there you can see on the power wire coming out, I'm running through 15 feet of 8-gauge wire. It looks like my flow didn't really change. So let me run this about a minute. So I'm at 6 minutes recording. So at about 7 minutes, I'll take the temperature reading. I'll go ahead and record the flow. So flow is identical. I didn't see a change in flow. So it's still 1.9. As expected, because this thicker gauge wiring, even though I added 15 feet, it didn't create any additional resistance in the circuit because it's thicker gauge, higher thread count copper wire. It didn't add any resistance, so it didn't cause any current draw change or flow change. So it makes sense. Actually, current did go down slightly, 15.2. So it actually caused an improvement. So even though I'm going through the longer wire, as the current draws from the power supply or like your battery or alternator in the car, as it draws through back to the driver module and to the pump, because there's more copper, there's more thicker wire, it's dissipating heat better, which also improves resistance. So that's why I saw a drop in current, 15.2 amps. And then I'm at 7 minutes. I'm going to do a measurement of the wire temperature. 55 degrees. So wire temp is 55 degrees. It's dissipating and holding the heat better. There's more metal, there's more copper, right? And shoot the pump. Pump is 72, same temperature. So pump temp is right here. It's the same temperature. Go ahead and shut that off. And then give everything a little bit chance to cool down for a minute while I'm swapping out the wire. So the last thing I'm going to do is test the 16 gauge wire. This would simulate trying to put this pump on the car without upgrading any wiring. This is simulating OEM wiring on the car, gauge and length, right? So I got the 24 feet of 16 gauge wire here. And this is like good wire. It's good thin stranded copper wire. It's high quality USA made wire too. So. All right, so that wire is plugged in, excuse me. Actually, I'll go ahead and, while I'm letting it cool. So right now the wiring is ambient, 54 degrees, which is what the other was after a minute of running. And pump is still, now it's like 69 degrees, so it's cooling off a little bit. So I'm not gonna let it, I have a good feeling of what's gonna happen here. One, this is too thin for the amperage and the distance. It's going to cause the wire to get hotter. It's going to cause more current draw, and I'm very confident we're going to see a flow loss. So the TI Auto pumps actually advertise one of the main specs of the dual channel single stage pump, single motor dual turbines in parallel at the bottom, 2 channels in the body and then 1 outlet. Dual channel single stage is the term. They actually have extremely good hot flow. So they have very low hot flow losses compared to a traditional 39 millimeter like 255 or a 340 pump. I've seen online anywhere from those pumps can suffer from 20 to 30% hot flow loss. Standard, just up to temp running in the car. you know, that's worst case scenario, no upgraded wiring, right? Upgrading the wiring will improve that on any pump, even a stock fuel pump, right? All right, so let it cool enough. It's 54. Now I'm down to 68. Okay, I'll go ahead and turn it back on. Let it run for a minute. So I started it at about 10 minutes. So at 11 minutes, I'll check everything. And amperage is up 16.8, so it's steady. So I picked up about an amp of current. And I did lose flow. 1.6. Wow. Ooh, 1.5. Oh, that's bouncing. I'll give it the benefit of the doubt. I'll call that 1.6. Right. And I'm at a little over 11 minutes on the video. Ooh, look at that. Wire's getting hot. So wire temp was in the 50s before. I'm at about a minute. And I'm up to, ooh, it pumps up to 80. I mean, that's pretty much cut and dry, guys. Like, I was expecting this outcome. It's really cool to get the data and see it. Because I've been doing this kind of wire upgrade stuff for fuel systems for like 10 years. The only other data I had is I put it on the car. Like, I knew the electronic theory behind it. So I built a kit for my car, a wire upgrade. And I saw duty cycle go down because the pump wasn't having to work as hard. It was flowing better. So it was modulating down to a lower duty cycle to get the same flow. So I'm actually this this wire is warm, guys. I'm letting it run a little bit. And imagine running this for 20, 30 minutes on your car. It's up to 90 degrees there. It was for a second. I can hold this steady. Still around above 82. It's climbing. I'm gonna go ahead and shut it off. I know I'm overheating that wiring. I can feel it. I can feel the temperature. Right, and then with the metal, when the temperature of the copper wire in there increases, the resistance also increases. So not only is there more resistance in the thinner gauge, longer wiring initially, as it's overworked, and the temperature of the copper wiring in there increases, resistance increases as well. So the longer you ran with inadequate wiring, the worse, the hotter your pump's going to get. The wire's going to overheat. It could melt. It could melt fuse holders, receptacles, right? It could start a fire. Upgraded wiring, guys. Pretty sweet. All right, and then I didn't record. Let's see what these were. I want to say it was up to like 90. Well, it was like 80 something at a minute. So wire temp was like 82. I can't remember what pump temp was. You'll have to go back. It was like 80, I think, or high 70s. So let's convert that 1.6. We lost a decent amount of flow. Wow. $363. LPH. Wow, guys. I can't write. So that's pretty substantial. So 432 minus 363. We lost 69 liters per hour of pump performance. That's pretty substantial. And let's get percentage. 16%. That is substantial. So I actually had someone message me last night. They saw my PPRV delete, and he's like, "Hey, I want to get it for my car." I was like, "What are you doing?" He's like, "Well, he had a 11 GT500, I think, which for some reason the 11 and 12s only have a single 12 gauge wire running back there instead of a dual 12 gauge like the earlier GT500s. So he had a pump die. And that's kind of a trend we're seeing. The pump wore out pretty quick. He had a pump go bad. He's like, yeah, I'm upgrading the pumps to the DW 340 liter per hour drop-in pumps, right? That's popular. And I was like, well, what mods do you have? And he's like, nothing, but I saw, the PPRV delete. I want to do that and get some performance back. And I was like, the first thing you need to do is upgrade wiring. So that's the most, guys will put a BAP on and guys will put in bigger pumps and they don't ever do wiring. You need to upgrade your wiring day one. Car could be stock pumps. You will see an improvement even on a stock pump. So there you go. Without upgrading your wiring, that 267 pump is losing 16% flow or 69 liters per hour. And then we upgraded to an 8 gauge shorter wire. Right, and the way you do that in the car is you do a wire relay kit. You use the factory wire to trigger a relay, and then you send the direct power path through a shorter, thicker gauge wire. And you get performance in your fuel system. So yeah, pretty sweet test. I'm not surprised. I didn't expect the loss to be that big, but I mean, I knew it was. I do a wire grade. I see 10 to 12% drop in duty cycle. Well, that's showing you how much flow and you were actually losing, and the whole temperature thing, right? The danger of overheating your factory wire. Some people will just put the pumps in. They're like, oh, I'll just put a bigger fuse in. The fuse protects your wire. So in your fuse panel, the fuse, based on the gauge and length of the wire to the load, because the current draws from the power supply to the load, to the pump motor in this case. So the fuse is protecting your wiring from, current draw on your wiring to keep it from overheating. Because if it overheats, it can melt, it can catch fire. So don't just put in bigger pumps or a BAP and then overfuse the factory wire. That's the worst thing you can do. And I know you guys have seen that because I see guys post up all the time, either premature pump failure or signs of heat around like connections or like a fuse, like the fuse actually melting. They put in a bigger fuse, so the fuse is never going to pop because I put in a 30, 40 amp fuse in place or whatever, higher fuse. Well, the pump was still only drawing 16 amps, so it's never going to pop the fuse, but it was quickly heating up the wiring because I'm no longer protecting the wire. All right, so that's it. Upgrade your fuel pump wiring. First mod you should do when you go to improve your fuel system. All right, thanks, guys.